Warning, in this video I'm going to be talking about high voltage and fuses. So if you are uneducated or incompetent in this subject, don't mess with it. It can cause electrocution and or fire. So there is the possibility of you electrocuting yourself and burning your house down at the same time. Okay, what I have here is a cheap power supply board I ripped out of some electronics. I keep power supply boards. I rob parts off of them all the time, or I use them in projects. I'll be using this one in a project coming up soon. They're real handy to have around. But this one I've got to connect mains power to it. And here in North America, we have a plug like this. So we have the small prong and then we have the wide prong. And yes, you're thinking it AC current, why does it matter which way it hooks up? It does. It's very important. And it's all because of this guy right here. And let me explain why. Alright, first things first. Your fuse. Your fuse needs to be rated slightly higher than what your circuit is designed to consume. That's just common sense. But the placement of your fuse is very important. You need to place it on the DC circuit on the positive side, and you want it as close to your power source as you can get it, because if you short, it will cause the fuse to blow where it starts consuming current. If your fuse is behind your load and you short here, then the circuit is going to consume the current through the load and then out the short and bypass the fuse. So always have it before your load, and preferably as close as you can get it to the power source. Okay, with the AC circuit, it gets more complicated. Alright, and here in North America, we use 240 volt from a transformer at the pole, and yes, it is 240 volt, and it's transformed with a center tap. So we have two 120 volt live wires and a neutral center tap. Alright, so it's very important with this plug. This is a polarized plug, which prong is which. The small thin plug right here is your live side, and this side is your neutral. On a lot of your circuits, you're going to have capacitors or even resistors that's going to draw from, most time it's on the live side, but it can draw from, designed to draw from one of the sides. So it's really important how that works. And also your ground. If you see here, your neutral side is the grounded side. So with your plug here, your wide plug, that is your grounded side. So when you ground your circuits, they need to be grounded onto the neutral side, so it gives you a path back to ground to save your life. And as you can see here, the live feeds to the breaker, then to your outlet, and then to ground off of the neutral side. Like I said, the neutral, what it does is gives a path for unbalanced current back to the transformer. So as your current's flowing through, your breaker is set up to flip off the live side, drawing current from the ground to save you. So it is very important that you you connect your polarized plug to the right side of the circuitry for design of the circuit. And the fuse here is designed to go through the live side to blow as it draws excessive current, just as your breaker is designed to flip as you draw excessive current back to ground to save your life. So like I said, when you ground, you should ground to the wide side. I hope this helps explain about the polarization of plugs and how the fuse goes on it. If you have any questions, leave me a comment and I'll get back to you. If you like this video, give me the thumbs up and subscribe, and you guys be safe out there.